know that you're breaking into the network, you just now rang the alarm bells and game's over for you. Now you have to come out and say, yes, here's my paperwork, and you have to go explain your life away, and your test is over, all right? So covering tracks, extremely critical. This is you're getting caught versus you're not getting caught, or going to jail versus not going to jail, depending on if you're white hat or black hat in that world, okay? So this is everything you need to pay attention to with our target. When it comes to Microsoft-specific systems, you need to know everything about authentication, realistically. Right? This is where the penetration tester has to supersede that of the network administrator once again, because you have typical Unix administrators or Microsoft administrators. Well, the penetration tester, they have to be a master at all of it. But specifically related to Microsoft, you must know how to access the Security Account Manager database on every type of system. You need to know everything about NTLM, all of the versions, what type of protection mechanisms they use, the old LAN manager systems versus NTLM version 1, version 2, because if you can find one system that has an old LAN manager capability, easy exploit, right? Or Kerberos. How do you manipulate the Kerberos process? Now, let's go and zoom out here to password-specific stuff. You must be a master of passwords. I said that the easiest way to get access to a system was to have a password, right? So let's talk about everything that there is to know about passwords. First one, and these are the areas you really want to study here. Passive online, all right? So the difference between active and passive is active is you reach out and touch your target, and your target knows and feels that. Passively, they don't know that you're doing it. So there's basically 3 major techniques in the passive category. Wire sniffing, if you can just listen to the network and you can get a username and password, and because the penetration tester, they must be an expert, again, at log file analysis and sniffing traffic. If you can just find that username and password combination, dinner bell rings. Man-in-the-middle attacks. If you can insert yourself into the middle of a conversation, well then everything gets disclosed to you, including the username and password, or perhaps the hash, or whatever goes back and forth. So this is another area to study. Another piece is replay attacks. This is where somebody sends authentication to a server, you get to capture that and then replay it at a later time. So why should I try to crack the password if I can just capture it and replay it? If the destination system says, okay, yep, that's what I wanted to know, let me in, okay, great, easy for us. Passwords, active online. So now we're reaching out and we're touching our targets. This is where attacks, especially in the wireless world, you do techniques like hash injection, or you can use Trojans or spyware, or simply start guessing. Right? There's certain science to actually just trying to guess a password, or using some sort of software like the social engineering toolkit within inside the Kali operating system and setting up a phishing attack. Right? Offline attacks. This is where we focus on hashing or distributed computer systems. In other words, multiple systems all working to crack a piece of the password space, if you will. Or rainbow tables. One of my favorite websites is Free Rainbow Tables. I think it's .org if I'm not mistaken. Either way, if you Google Free Rainbow Tables, this is easy enough. Because literally there are gigabytes and terabytes of just rainbow tables of stuff that has been hashed. So we're going to take apart the rainbow table process. You must master that. And then the non-electronic means would be things like shoulder surfing, social engineering, and of course digging through the trash. So that's the 4 major areas of getting a password. Passive online, active online, offline, and then non-electronic. Let's go over to one other area here. Rootkits. There's several different types of rootkits in which the penetration tester must master and be able to do all of this hands-on. Now, I want you guys to pay really close attention. None of this is worth a dime if you can't do the hands-on. You can talk about this stuff in theory all day long, but you'll never get a job, you'll never be a penetration tester, you'll never have a career unless you can do all of this in a hands-on format. All right? So the difference that's going to separate you guys from everybody else out there that doesn't know what they're doing is you're going to be able to do this in a hands-on format. So rootkits. being able to create a firmware rootkit or a hypervisor rootkit for virtual machine software, or inserting a kernel level rootkit into like the operating system of Microsoft or Linux or something like that. Application layer rootkits, library rootkits for application programming languages, or even bootloader rootkits. Right? So the whole subject matter of system hacking could take years and years and years to master, and we can have that time if we need it. But let's look at the common countermeasures that are put in place, and then we'll wrap this up. Salting. This is a particular technique. It really should be a lot more popular than what it is, but most systems do not use salting. For why, I have no idea, because it's such an easy technique and it defeats a lot of the rainbow table style attacks. So we got to know what salting is and when to use it or when to look for it. Also, your run-of-the-mill anti-rootkit or anti-spyware type programs. That's a great countermeasure to defeat this type of attack. One of my favorite, albeit training, making sure everybody knows what the heck they're doing. Whether it's training employees, training system administrators, training penetration testers, training. The problem with training is that most of the time there's a problem, and so we fix that by sending someone to training. That's not the way training is supposed to work. Training, my point being, why not train them to know how to do it securely the first time so that there is no incident in which you have to detectively and reactively send someone to training. So preventatively versus detectively and reactively. I always suggest that training should be done proactively, and therefore you can address the knowledge gap and things like that. Also, hardening your systems. If you look at the target in terms of a surface area here, zoom back into the target for a second here, right? If we could take away all, from a defensive point of view, if we could start taking away all of the penetration testers' options, in other words, we don't give the penetration tester the ability to eavesdrop, we don't give them the ability to brute force or go after passwords, we monitor accounts, remember this is all defensive, we monitor accounts to see if someone's trying to crack passwords or do privilege escalation, or we monitor software on hard drives and operating systems to make sure that Trojan spyware and keyloggers aren't installed. If we constantly are looking for hidden stuff to detect it and correct it, so that way alternative data streams aren't left on the systems, or people aren't using stenography, or we're constantly doing log file analysis. If we defensively take these options away, well then the penetration tester has nothing. This is literally from a pen testing point of view where if I don't have any options here, I start scratching my head and going, we're going to have to get really, really creative because the surface area of the attack is slim to none at this point. I don't have any options here, which means that that target system is secure. But the more I have here to work with, the more I can go after that system. Literally, there's hundreds of hours worth of attacks and techniques that it can be applied just having that. So if defensively, if you can take that away, well then the penetration tester can't do anything. All right. So harden your systems, takes these options away from a defensive point of view, and this is where things like STIGs or Standard Technical Implementation Guidelines come in, and mastering those, because these are all of the best practices for hardening our systems. And there's plenty of ways in which you can go after STIGs, and that's really its own conversation. And the last piece is common sense. It used to be called common sense, but it's not so common anymore, right? From a pen tester's point of view, I laugh a lot of the times. I'm like, well, they just left, a trail of cookie crumbs for me there. I'm just going to follow that trail and see how far the rabbit hole goes. Well, that's because the network administrators or the defensive people realistically aren't applying common sense. Or even if they wanted to apply common sense, they're getting lost in the processes, the procedures, and the technology, and they can't stop me for whatever reason. So if you can't stop me, well then I'm going to exploit your systems, I'm going to write a report, and I'm going to show you. And I'm going to say, look, here it is. Here's the attack. Nothing is more valuable than getting access to a CEO's inbox and putting your resume on their desktop. That is your bread and butter. Case in point, yes, I hacked your system. Okay? You want to send the message? That's a great way to do it. But if I can't do that, well then, what does that say about your defensive techniques? Well, they have to be pretty good in that case, right? So, apply common sense. Let's not get lost in the policies, the standards, the procedures, and the guidelines, and get lost in the run-of-the-mill way in which IT is done, meaning the patch management process, the change control process. If all of those were robust and efficient, well then that makes my job as a penetration tester that much harder. Okay? So, quick summary. We're at the first point where we can change the integrity of our targets. We're not only using disclosure, like what a password is, but we're also explaining the system in terms of integrity. There are plenty of things that we can go after on our target: gaining access, escalating privileges, executing applications, hiding stuff, and covering our tracks. Since most systems out there tend to be Microsoft, the biggest bang for your buck is to learn Microsoft systems first. Know everything that there is to know about the different password techniques, learn how to use rootkits to your advantage, and learn the common I want to start off this module with a little bit of a quote. Start off with a quote is you really got to dissect this quote apart. Obstacles in the mind. In social engineering, what you're doing is you're taking away, removing, or alleviating these obstacles in the mind that someone may have to overcome what obstacles may be in the journey. Okay, so let's say we want something like, a password or something like that. Well, if you could strategically plant information in someone's mind, well, they might strategically voluntarily give you some information that could yield a password. Okay, so keep that quote in mind as we move throughout social engineering. Let's take a look. Okay, the targets here. The targets are often office workers because they are the closest to our assets, or the closest to the things that corporations typically want to protect. It's certainly not limited to office workers. I mean, realistically, anybody can be socially engineered. But the context of this module, we'll keep it at social or office workers. Okay, the skills in which you need to be good at social engineering really have two foundations. One is based in the science, and the other is based in the arts. Okay, so there's technical ways to do this, but there's very much an artistic craft to social engineering as well. So good interpersonal skills add to the value of the person doing the social engineering. It's also helpful to be very, very talkative. The more talkative you are, the more conversational you can be, the more information you could ultimately get out of someone. Also, it's a great idea to be creative. Why try to break AES 256-bit encryption when you can socially engineer the password and get access to what you need? So we always want to take the path of least resistance. Good communication skills kind of aid in being talkative and creative as well. Now, the most common mechanisms in which we carry out social engineering attacks are basically emails, on the phone, or in person. Any one of those mediums is fair game in terms of carrying out a social engineering attack. Let's go into the techniques. Okay, there's a lot of different techniques in which you can apply, but here's just a handful of the basics here. From doing this on a computer, someone can be socially engineered. Someone could be socially engineered through spam. Right? Just send someone an email. You've won $1 million. Click here now, right? And they want that $1 million, so they'll click on the link. Through chat is an easy mechanism because we typically don't authenticate chat conversations, or we assume that the person on the other end of the chat line is the person in which their name or handle is. Chain letters, hoaxes, even pop-ups. phishing attacks or any derivative of phishing attacks. Later we'll talk about spear phishing specifically. It could be a fake application or through SMS text. You could easily text someone, hey, I lost my contacts in my phone, please validate blah 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 blah, right? And that's an easy way to do it, just over phone text, or even over social sites. Being that we're all connected socially, there's been a surplus of fake profiles that have made it to LinkedIn and Facebook and Twitter and things like YouTube and things like that. So while computer techniques are very, very popular, it's certainly not limited to that. Human, okay? You could just show up live and in person, do this one-on-one, right? Pretending to be a legitimate person or an important person like a CEO or a new hire or something to that capacity. Or the most common is probably being part of the support staff. Hey, I'm so-and-so, I'm here to fix your computer, give me your username and password, and I'll go ahead and fix it and get you back to work. Pretending to be support staff. Spear phishing, very, very targeted phishing. Phishing is just, fake emails that go out pretending to be something, but spear phishing is now you're targeting. The reason why we call it phishing is because you're just throwing out a net and seeing what you catch. Well, now you're just doing that in a highly targeted manner. Your net becomes a lot smaller or a lot focused to your target. Nowadays, we can also do it over the phone. Okay, so it happens in the mobile application. There's been a handful of malicious apps. It could be something as simple as everybody wants additional batteries on their battery power on their cell phone. So maybe there's a fake app that says, hey, boost your battery life by 35%, and somebody's in their app store and they go, oh, I really, really need to do that. So they download this malicious app, and the malicious app profiles their phone and then exfiltrates data from their phone. It could be eavesdropping. Right? Just passively listening and paying attention to certain things depending on where you are. It could be while you're in a customer service line. It could be while you're at a lunch line. Something as simple as that. Shoulder surfing. You could be in an office place and just happen to be looking over someone's shoulder and gain access to information. Or basically watch them type their password a bunch of times, and each time you focus on a different finger. I mean, if they use this finger, how many times when they log into a site, well, then you know at least what characters their password is made up of, and then you can slowly start building that password. Dumpster diving, simply going to the trash. Tailgating, following someone through an access control point. It could happen in person. You can have reverse social engineering. There's books on the subject of reverse social engineering. In other words, instead of me trying to social engineer you, I present myself in some way where you feel inclined to voluntarily give me the information. So instead of me trying to get it out of you, you voluntarily give the information to me in hopes of some reward later. Or piggybacking, which is a derivative of tailgating. Now the impacts here, okay? Organizations can suffer drastically for a variety of reasons. Social engineering just happens to be one of those ways which you can suffer large amounts of impact. So let's look at what impact means. It could be a loss of privacy, right? It could be something as simple as a password, but that password could get you access to more sensitive information like confidential or secret or top secret documents or something like that. You could result in loss of goodwill or loss of reputation to an organization. In the worst case scenario, you could go out of business, right? Depending on what the nature is of what got socially engineered, you certainly could find yourself out of business. Nowadays, you're seeing it in terrorism. Okay, financial loss. What if it's the secret ingredients of Colonel Sanders' secret recipe, right? Well, if that's proprietary information that's critical for a company to survive, and now all of a sudden everybody can make that great chicken, well, then the information is no longer confidential, and your competitive advantage may be lost. Theft. Now, traditional theft would yield, bank accounts and credit card numbers and things like that, but there's really nothing that you couldn't limit yourself to. Identity theft, that's a big topic all in itself. What's the identity theft market worth these days? I heard it's multiple billions of dollars. So why does all of this happen, right? It happens because really in the world of social engineering, you're taking advantage of human nature. You're using your social skills to strategically get something out of someone, right? So people want to naturally be helpful. Well, if you can use that to your advantage as a penetration tester, well, then you do, okay? Also, ignorance. Well, this is I didn't know, I wasn't supposed to give them that, right? If they didn't know, they weren't trained, well, that's why you can get this valuable information, or why you can be socially engineered. Open promises, okay? That's just another one. You could promise something, somebody give you something, and then you'll never make good on that promise. Meanwhile, you already have what you need. You perform your penetration testing attack. This often ends in the context of, well, I'll be back in a few minutes and I'll give you the information that I promised you. And meanwhile, you never come back. Okay? They feel morally obligated to, right? They want it to be helpful. This is where, you pretend I've got to work here late and it's going to take me 5 hours to do this, but if I just had that password, I could leave with you. Well, the person that you're telling that to, they may feel morally obligated to, I'll just give you my credentials so you can get the job done faster, so you don't have to stay here all night and work, okay? No training. Simply stated, people aren't trained, they're not aware. Look at the demographics of the office space. So if people aren't getting trained, they don't know about this stuff, they don't know when they're getting socially engineered and when they're not getting socially engineered. And that makes getting a password 60 and 70% of the time very, very, very likely. Also, a lot of this information is easily accessible, so you're just naturally walking around the workspace or office space, and if things are easily accessible because you don't have a clean desk policy or something to that nature, well, that could result in a social engineering attack. Weak policies, and also it's difficult to detect. In the world of viruses and Trojans, it's pretty easy to write a signature to say, hey, meet this criteria, okay, alert. Well, if people aren't trained, tying into it being difficult to detect, how do you really know if you're being socially engineered? How do you know just the person isn't trying to be a good person, okay? So those are just some of the top reasons on why social engineering happens. The value here in which the penetration tester is generally going after, okay? We can chalk this up to confidential information. Ideally, you'd like to get some sort of authentication or authorization information so that you can get access to things that a regular user, or in this case the pen tester, doesn't have access to. So some sort of authentication or access control. Those are very, very valuable in the scope of social engineering. Some of the tools that we will use are the Social Engineering Toolkit. This is the first really major project where there's a computer program and it walks you through a little wizard or tutorial, and you can craft your phishing attack or craft your social engineering toolkit attack and then go ahead and launch it. Primarily in computer-based attacks, but there are some script-oriented things for being in person. So let's go ahead and talk about some of the countermeasures. If you want to stop social engineering to your organization, well, best practices apply here. Simply stated, change your passwords. Because penetration testers are looking for authentication and access control, something as simple as a change of a password on a regular basis and not using, the same password over and over and over again, that reduces the likelihood of the penetration tester being successful. Also, you'll see these in the financial world: account lockouts, account logout functions, or account expirations. Not to say that it's not limited to just the banking or the financial world, but you'll see those a little bit more. Like if you go to your bank account, if you have 15 minutes of inactivity, boom, you get locked out, or logged off rather. Training, all right? If people were trained on what social engineering is, then they might be inclined to not participate in what they would think would be a social engineering attack. Also, keep sensitive information secret or private. It's just that simple. If you know what is sensitive because you have a classification system, well then you're not going to disclose it to people who don't have that access. Also, when it comes to a facility, any sort of guests should ultimately be escorted, and those escorts should stay with the people that they're escorting. Shred your documents. Have strict access control techniques. Use a classification program. One of my favorites, since I have a background in incident response, is actually have a capability to identify, detect, contain, eradicate, and recover social engineering attacks, along with any other attack. And they don't have any sort of criminal background, then that should help. But just the background checks in itself kind of is a screening piece of it. Also, use two-factor authentication. Remember the multi-factor and the two-factor, okay? This is based in something that you know, something that you have, and something that you are. So instead of just authenticating with something that you know, use two-factor means now you're using something that you know and something you have, or something you have and something that you are. Okay, so we call that two-factor or multi-factor. Use a change management program. That way you can track changes throughout the organization or improvements. And then, of course, antivirus or anti-phishing software. Now, with the whole subject of social engineering, there's a whole landscape here in which the penetration tester can be very, very creative and ultimately get sensitive information. Again, this is an art and a science, but let's go back to the quote from the beginning, right? Obstacles in the mind are more important than obstacles along the journey. We're going to use these obstacles in the mind and overcome them in someone's mind so that we don't have those obstacles throughout the journey. Or let's say throughout the journey we want to get to some sort of sensitive or critical information. Well, if we can tap into somebody's mind using our social skills, well then they might voluntarily just give us the account information or give us the passwords. And that's why it's really important to approach this as not only a science and all the computer stuff, but also using your interpersonal skills and communication skills so that you can achieve your objective. So that is the basic makeup of social engineering. Welcome to web application pen testing. This whole module is huge. There's so much that we realistically could do here. It could take months and months and months to build proficiency here. This is its own course. This is its own subject matter. This is its own field of study. So we're going to highlight it as opposed to get into all the nitty-gritty details. So it has to deal with web applications. There was a book written some time ago called The Web Applications Hacker's Handbook. and it will be the go-to book for years and years to come. This book has been light years ahead of just about anything that you'll find on this subject matter. There's also some really other good books out there. I don't want to discount those, but this is basically the new foundation for how to approach this whole field. Okay? So the concept here is, besides the obvious of web applications, it's what are all the components of them, how do they go wrong? So let's start here with some basic concepts here. Because they're web applications, this is where we get cross-site scripting. It exploits the relationship between the client and the server, cross-site scripting. Oh, you also have vast amount of information leakage. Some of it out there, which is non-harmless or not harmful in itself, but could result in a secondary attack, which could be harmful. Okay, so information leakage. Things as simple as error messages. Well, at first they don't seem like a big deal, but if that error message okay. Content spoofing. Okay, websites hold content, legitimate content and bad content, so you can spoof that content. Okay, weak authentication. Everything about the authentication process. I mean, authentication in a nutshell is, I'm a claimed identity, prove it. Okay, well, we all connect to a web server, so let's exploit that relationship. Cross-site request forgery. You kind of have to deal with this one backwards. It's a forged request that goes from one site to another. Brute forcing, okay? Mom, are we there yet? Mom, are we there yet? Mom, are we there yet? Keep trying things over and over and over and over again. If someone is not monitoring the web application, you can just have at it. Predictable resources. All right. For example, it's pretty well known that you can go to /administrator, and that's normally the administrative login for the web portal. That stuff realistically should be changed. SQL injection, its own field of study in the terms of databases. Well, most web resources are stored in a database, whether it be MySQL or MS SQL or Oracle or whatever the database is. SQL injection is its own field of study. Session fixation. This is where the hacker has some information and he needs to get a victim to concentrate on what the web hacker is now saying, hey, please click on this because this will get me in. So you've tricked the user into clicking on something, and that ultimately exploits something. No session expiration or indefinite session times. This is also another problem with web servers. Web 1.0 concepts versus Web 2.0 concepts. Web 1.0 concepts, these were more or less static sites or resumes, or it was all about the business at hand. Web 2.0 is less about the business and more about the end users using the website. So a great example of Web 1.0 versus 2.0 is just a very static web page. That's Web 1.0. Things like YouTube or any customer-oriented website like YouTube, where it's all user-generated content or user-generated features, those are Web 2.0 concepts. So let's look at those just a little bit more. Things like blogs, all right? If you can have everybody and their uncle go to a website and post a blog, well, it's user-generated content, therefore Web 2.0. You have concepts like AJAX. Google uses these, YouTube uses these. This is when you start typing and it starts to predict and narrow down what you're actually searching for. Or even Flash, you could consider that Web 2.0 oriented. Or tools like jQuery, or cloud concepts in general. This is really storing things out on the internet in some sort of public fashion. Like a great example of cloud storage would be Dropbox, or Wikipedias, or online dictionaries and things like that, or gaming sites, or even traditional RSS or social networking in general. So we're very much Web 2.0 now. It's all about the end users and making the website valuable for the users. The site that you're on right now, Web 2.0 oriented, it's focusing on the end users, okay? So when it comes to hacking web applications, there's all sorts of threats that could go wrong, okay? Things like cookie poisoning. web servers store little pieces of code on your client-side computer. Well, you can poison them. Directory traversal, navigating, predicting, and enumerating what the directories look like. Very easily, you can figure out if it's Unix-oriented or Apache versus Windows-oriented. Unvalidated input. Okay, can you just supply anything to the web server? SQL injection. Notice I have a note here, cheat sheet. I use cheat sheets whenever I possibly can. SQL injection cheat sheets, cross-site scripting cheat sheets. Apparently I can't say the word cheat sheet, but that's okay. Use them, okay? Use them to your advantage. Instead of trying to memorize all of the possible combinations of SQL injection for MS SQL or MySQL or Oracle, use cheat sheets. Use them to our advantage. Same thing with cross-site scripting. You want to know what they look like? There's plenty of cheat sheets out there. Use them. It's a great way to kind of keep a lot of information on the tips of your fingers. Cross-site request forgery, we've already talked about. Form tampering, insecure storage, or how does the web server store its information that the users are uploading? Are there picture directories? Are there video directories? What are the permissions on those directories? How are you handling errors? Are you, giving an error message to your end user? Does the end user even need to see that? Buffer overflows are its own field of study. Log tampering, clearing your logs, changing the integrity of them. All of the account management. Remember, Web 2.0 is user-centric, so users are going to need to have accounts. How do you manage them? How do you do things like password reset functions and things like that? How do you manage sessions? Can you just go to the online site and add something to a checkout without creating an account? Well, ultimately, you're storing things on a server. Okay, platform-specific exploits, either the application in themselves, be it Joomla, Drupal, WordPress, or maybe at the operating system level, is it Unix versus Windows, etc. Authentication hijacking, see the session hijacking module. Cookie snooping, just finding out what's in the cookie in itself. Session fixation, tricking the user. Malicious code execution. Denial of service, that's its own field of study. No encryption, no SSL, no IPsec, no transport level security, even XML poisoning. These are all potential threats for things to go wrong in the world of web application pen testing. So let's look at the countermeasures. Become an expert. It's really that simple. Normally I like to list off, the top 10 or 15 here. In this case, there's just way too many. I would fill up this whole board 4 or 5 times over. There is so much that goes on specifically in this subject matter. You have to become an expert. This is not something that you're going to learn overnight. Learning each one of these techniques, just learning cross-site scripting and form tampering, that could take a while to learn, as opposed to buffer overflows or SQL injections. Some of it's, you have to learn the whole field of databases before you can just become good at SQL injection. Versus, you want to become a great web application pen tester, you have to understand all of the components of HTML. One of the best tools out there for learning this is a tool called the Burp Suite. It is something that you can use to dissect the web process over and over and over and again. So let's go ahead and look at some hands-on examples. All right, welcome to the SQL injection module. Lots of exciting stuff here. This is another module where it could take years and years and years to really master this stuff and get it to the point where you can just do it. So there's modules where you can have a cheat sheet, okay? There's lots of different database languages, and so if you're going to go from MySQL to SQL to Oracle, etc., use the cheat sheets. It'll help you remember how it works in one particular language or the other. Also, most database people, they know MySQL inside and out, but they may not know Oracle, or they know MS SQL, but they may not know MySQL. Realistically, it's just databases, and different databases speak derivatives of the same language. It's kind of like if you learn Spanish, it's not too hard to pick up Portuguese or Italian for that matter. Okay, so concepts here. Okay? Ultimately, you have to be able to analyze between the client and the server. And that all starts with something as simple as an HTTP post request. Okay, this is where we can sniff traffic and analyze that request. It could be a network sniffer like Wireshark or TCP dump, but it also could be like a tool like the Burp Suite to basically dissect this client to server traffic. Okay, if you look at the client talking to the server on a normal conversation, this is what we call normal code analysis. And you need to, for the pen tester needs to understand what normal analysis looks like, so then they can start deviating from the norms to get the computer programs to basically do what they want. Okay? Ultimately, in database language, this is what it's going to come down to. There are certain parameters like the update parameter. This is when a client sends to the server and says, hey, I'd like to update something in the database. Okay? Or select something from the database where the values are equal to, whatever they are. Okay? Or get something from my table. Okay, just a generic table name in that sense. Or just drop the whole field, the record, the row, the column, the database, or the table. Okay, so it's everything about the client to the server. Once you get to the table, once you're in the particular, or the database, then the table, and once you get to the table, then it's the columns, then it's the rows. Okay, so you can kind of think of this hierarchically. Let's talk about some of the attacks. Ultimately, what you can do if you get really skilled at SQL injection is remote code execution. That's good. Also, you can knock the database offline, therefore nobody else can access it. That's an attack on availability. You can use tricks like bypassing authentication, maybe send the admin credentials followed by a single tick and -- which is a comment field, and then comment out the requirement for the password. All right, maybe just get directly into it as admin. A little bit of a dated technique, but nonetheless, in the older days of SQL injection, it was just that simple. Just comment out the password field, and the server would just follow the programming logic. Okay, no password, fine with me. All right. Information disclosure, whatever's in the database ultimately could get disclosed. There are advanced SQL injection techniques, or at least I'll show you the theory in which you can start enumerating database names, table names, column, rows, and then field names or field characters. You can change the integrity of the database and the tables. You can do things like password grabbing. You can transfer the whole database from the server to the client. One of my favorite techniques. One technique, you got the whole database. Or allow the database to interact with the operating system. This is